Today is Saturday, March 19th, 2016, and as you can see, in just over 24 hours time from right now, it is going to be the March Equinox for 2016. As you can see from timeanddate.com, we have the event time of 4:30 AM UTC on Sunday 20th of March 2016. Now here in New Zealand we're on daylight saving time, so we're an hour ahead of normal time, so the event time is 5:30 PM on Sunday 20th of March 2016. And as we scroll down we can see the local times for the equinox at other locations around the world. Now using the Seasons and Ecliptic simulator we can see what's going on with the equinox. Down here the date is set to 20th of March. Now the Earth is tilted on its axis at an angle of 23.5 degrees. On the equinox the tilt of the Earth is the same, and so the days and nights are equal. This is where we get the term equinox from. You can see that when I move the position of the Earth around the Sun throughout the year, you can see the months at the bottom of the screen, the tilt points in the same direction, but because of its position around the Sun, then in summer the northern hemisphere is tilted towards the Sun, but in the winter the southern hemisphere is tilted towards the Sun. But on the equinox, the tilt of the Earth is side on as seen from the Sun. This means that the light from the Sun is coming straight in towards the Earth, and the days and the nights are equal, hence the term equinox. As well as having equal day and equal night on the equinox, the other thing that it means is that the Sun is rising due east and setting due west, as we see here with this heliacal rising simulator. Now, if I lock the time to sunrise and rotate this so that we have a better view, you'll notice that when I change the date, the Sun's position at sunrise changes along the horizon throughout the year. But it is only on the equinox in September and in March that we see that the Sun is rising due east and setting due west. The equinox gives us a unique opportunity in the flat Earth debate to check the position of the rising and setting Sun on the equinox and check to see if our observation fits what we should see for a flat Earth model or a globe Earth model. According to the globe Earth model, it should not matter where you are on the Earth, your sunrise should be due east and your sunset should be due west. I can change the latitude to anywhere on the Earth and we see that the Sun's position remains due east. Now my latitude is approximately 37.5 south and the Sun will be rising due east. Again, if we change this to sunset, we have the Sun over here due west, and again I can change the latitude to anywhere in the world and the Sun should be setting due west. So how would this fit with a flat Earth model? Here is a high resolution map of the Earth using a flat projection. It is often used by flat Earth believers as a flat Earth map. Let's zoom in and take a closer look. Here is New Zealand, and I mentioned that my location is at about 37.5 degrees south. I'm in the Bay of Plenty of the North Island of New Zealand. You can see that I've drawn this red line to represent east and west, as seen from my location. When the Sun is rising on the equinox, I should expect the Sun to be rising due east, and it will cross over my northern sky, because I'm in the southern hemisphere, and set due west. Now let's take a closer look at that from the flat Earth point of view, and see if it works. According to the flat Earth model, the Sun and the Moon rotate around the sky above the flat Earth disk once a day, as we see in the simulation. If this orange circle represents the path of the Sun as seen in the flat Earth simulation, then we already have a problem, because obviously our rising and setting position is nowhere near the red line that I drew, which is due east and due west of my location in New Zealand. So let's move the orange circle over so that the Sun is rising and setting due east and due west. But you see, now we have another problem, because even if my Sun is rising here due east and setting over here due west, as shown by the red line, the problem is that the Sun is now crossing over my southern sky, but I'm in the southern hemisphere and the Sun always crosses over my northern sky, Now the other obvious problem is that the orbit of our Sun is much too small because this side is pretty much right over the North Pole, so I need to make the circle larger. Now having made the circle wider, we see that we still have the same problem. On the 20th of March on the equinox, the Sun will be rising due east over here and setting due west over there. It will be arcing across the northern half of my sky, as it always does, but according to this it will be orbiting around the southern part of my sky, south of New Zealand, which doesn't occur at all. Again, here is the simulator, and we see that the date is set for the 20th of March, and my latitude is 37.5 degrees south, and we can see the Sun rising in the east, and it crosses over the sky in the northern part of my sky, not the southern part of my sky, and it sets due west. So now I've drawn another line here horizontally across the central latitudes of the United States, showing the due east and due west directions which they should expect to see the Sun rising and setting. And yet again we see the same problem. Now for the equinox, it doesn't matter where we are on the Earth, the Sun should be rising due east and setting due west. But this can't be true for everybody on a flat Earth, because obviously if the Sun is rising due east at the central latitudes of the United States, it therefore cannot be rising due east for my latitude in New Zealand. And the opposite is also true. So tomorrow being the equinox, the 20th of March 2016, this is a great opportunity for people to see if the Sun is indeed rising due east and setting due west. Now if you're going to rely on a magnetic compass to show you where due north and due west and due east is, you're going to run into problems because magnetic north is not always the same as true north. In fact, in New Zealand there is approximately 20 degrees difference between true north and magnetic north. But there is another way that you can check to see if the Sun is rising and setting due east or due west from your location, and that is to use Google Maps and zoom into your location, for example in Los Angeles, and find a street near you that has roads running due east and due west. As we can see here, there are plenty of streets running due east and due west. Now if you want to be really accurate, you could open this in Google Earth and just make sure that it is precisely due east and due west. But for example, you could use any of these streets here to check that the Sun is rising at the end of the street or setting at the end of the street. So let's see if the Sun is indeed rising due east and setting due west on the equinox, and let's compare our observations. And I'd be particularly interested to hear from people who, like me, are in the southern hemisphere, to find out whether the Sun arced across the southern half of their sky or across the northern half of their sky as we normally do. Because obviously, according to the flat Earth model that we see here, with the circuit of the Sun around the disk of the flat Earth, the Sun would have to cross over in the southern part of the sky for the southern hemisphere observers, and that just does not fit with what we see every day. As always, do check out my Facebook discussion page, Voices of Reason to Explain X, or VORTEX. You'll find a link in the description area. Thank you for watching. Hello YouTube, this is Dazza the Cameraman. Today is Saturday, March 19th, 2016. And as you can see, in just over 24 hours time from right now, it is going to be the March Equinox for 2016. As you can see from timeanddate.com, we have the event time of 4:30 AM UTC on Sunday 20th of March 2016. Now here in New Zealand we're on daylight saving time, so we're an hour ahead of normal time, so the event time is 5:30 PM on Sunday 20th of March 2016. And as we scroll down we can see the local times for the equinox at other locations around the world. Now, using the Seasons and Ecliptic simulator we can see what's going on with the equinox. Down here the date is set to 20th of March. Now the Earth is tilted on its axis at an angle of 23.5 degrees. On the equinox the tilt of the Earth is the same, and so the days and nights are equal. This is where we get the term equinox from. You can see that when I move the position of the Earth around the Sun throughout the year, you can see the months at the bottom of the screen. The tilt